Morning, friends. We're back. What I have you guys looking at right now is the finished graph that you should have. You'll notice that it kind of looks like a mountain. So, as you can see, I took all of these points here and then I plotted them on the line graph and then I connected all the lines. And we're going to use this graph to answer all of our questions. Okay? So, after your graph, you should be past all of this now, and we should be on number 4. Okay? So it asks, during which seasons did the days with the most hours occur? So seasons, we're talking like spring, fall, summer, fall, or winter. And we're kind of looking at, where on our graph the months show the most daylight hours. So looking at this, it looks like a mountain. And if we look close to the mountaintop, I would look at like these 3 points here. Boop, boop, boop. Okay, we know that this point is June. Okay. So we know June is smack dab in the middle of summertime. Same with July. And then if we go back one more, it would be May. So May's like late spring. So for number 4, I would say that the seasons with the most daylight hours are going to be late spring and summertime. All right, number 5. During which season did the days with the fewest hours of daylight occur? So we're just looking at the opposite. So we look at our mountain-shaped data here. We go down to the fewest. Okay, this is January's. Okay, January, February is kind of at the base of our graph here. We know that January, February is like wintertime. Okay. And so we say early winter. And then if we go down here to the other base, we got like October, November, December. We know that that's like late fall, right? We know fall starts to hit, especially here in Washington, right around October. It's almost like day or night. It's like, hey, September's really sunny still. Yay. And then October comes and we're like, brr. So I would say winter and like late fall for number 5. Okay. Number 6. So what patterns do you see in the data? Explain what we see. This is kind of a you thing. If you have an answer that makes sense, then that will be fine. A pattern is something that you can see. I will tell you what I see. Okay. The pattern that I see, it looks like a mountain. Right? From January to June, the pattern that I see is that it increases. The daylight hours increase. The closer we get to June, the longer the daylight hours are. Okay, and then right after that peak in June, I notice that from June to December, what happens? The amount of daylight hours gets less, so it gets darker quicker. Okay, so that's the pattern that I see. All right. Number 7. So make a general statement about the number of daylight hours or daylight changes throughout the year. Okay, so this is pretty similarly. The longer we go through the year, when we get about to the halfway through the year point, the daylight hours are at their max, and then the closer we get to the end of the year, the daylight hours have decreased significantly. So basically, with the first day of winter at the starting point, the number of daylight hours increases for the first half of the year, and then for the second half, the daylight goes down. Okay? All right. And then we have number 8. What do you think causes the changes in the number of daylight that you observed? Explain. So what makes this happen? Why do we have longer daylight hours during some parts of the year, and then we have shorter daylight hours during the last half of the year? So we know that the Earth is tilted on its axis. We also know that the Earth revolves around the sun in an elliptical pattern, which is an oval shape. Because of this, light only shines on part of our Earth at one point in time. So during the first 6 months, we're facing away. We are facing away from our Earth. Only part of our planet is getting the most light. So as it turns and it's tilted, we have less daylight hours just because we're not facing toward the sun. And as we get closer and closer to June, we are facing more toward the sun, and allows us to get more direct sunlight for longer. And then as we make our way away from the sun in our elliptical orbit pattern, then it starts to happen where we're getting less and less direct sunlight. We're still getting sunlight. I don't want you to think that we just don't get sunlight anymore. We still do. It's just we're not getting it directly. You know, if you look at my lamp here, I mean, the lamp is shining directly on my hand, and the further I get away from it, the more dim my hand gets. You know what I mean? So it's kind of like that idea. Less direct sunlight means less heat and less days, or less daylight. Okay? All right. And then let's see. Yep, here we go. Last one. Predict during which month the day with the most hours of daylight will likely occur next year, and explain. What do you guys think? I think it's going to be exactly the same. Remember, we talked about wobble, and we talked about how the Earth spins on its axis and it wobbles kind of like a top. But we also remember that it takes a very, very long time to happen. So it's safe to say that this same pattern is going to be it's going to happen again next year and the year after that for a very long time. We're not going to really notice a whole lot of difference in the pattern of daylight hours. So I predict that it's still going to be June. Okay? The same pattern that happened this year will likely occur again every year, including next year. Okay? All right. If you guys have any questions, I will be in Google Meets today from 1 to 2 o'clock. Feel free, drop in. Ask me any questions you guys have about the graph, about the data, I can actually maybe show you guys some more like, here's what the Earth looks like, here's the light shining on it. It's kind of hard for me to do right now because I'm holding the phone with one hand. And yeah, or drop in just to say hey. It'd be good to see you. All right, guys, have a really good day, and we will talk to you soon. Bye-bye.